Hi, everyone. It is a pleasure to be kicking off this webinar today. My name is Narindi Chan, and I am an Azure Solutions Area Lead for the US, supporting our small and medium-sized customers here at Microsoft. Here with me today, I have the pleasure of introducing Ilanet Theyrahman Parnas, VP of Marketing for 2B Cloud. She has held several marketing roles across different customer segments and VCs over her 7 years of experience. She currently joins us from one of our Azure expert MSPs, 2B Cloud, helping our customers migrate and modernize on Azure. Ilanet will be diving into the journey from physical computers to serverless technology and the evolution of cloud computing, its benefits, and much, much more. Feel free during the webcast to put your questions in the chat window and continue asking as time permits. And with that, I will hand it over to Ilanet to kick us off.
Thank you, Narindi. That was an amazing pronouncement of my last name. So thank you and hi, everyone. I'm Ilanit, VP Marketing of 2B Cloud. So I'm very excited because we have a lot of things planned for today, but just quickly a little bit about us. So we are we are a Microsoft partner, specialized in tech companies. We are an MSP expert with advanced specialization in Windows and SQL Server migration, Kubernetes and Azure, app modernization, and many, many other things. Our passion is really working with tech companies and helping them utilize Azure and seeing them grow. So what we're going to try to cover in our 30 minutes together. So we're going to quickly discuss the evaluation of cloud and how do we got to where we are today, the 3 different cloud computing models, the difference between serverless and containerized, which is like all the buzz right now. What are the different principles? What is better? And of course, leave some time for Q&A. So let's get started. What does cloud computing mean to you? Like, we are here, of course. Everyone is always talking about it. This is the next big thing. But what comes to mind? Like, don't be shy. Write things in the chat window. I really want to hear what you guys have to say. So keep on writing. I have prepared in advance a few answers that I always hear when I do this lecture. So we do hear a lot that a quicker time to market, it allows freedom. The whole discussion about is it cheaper or not, it really depends on how you look at it, but it is cheaper. A lot of the things that I hear right now that is just a buzzword. But it's not just a buzzword. I do have to say that when I do this with high school kids and I ask them what cloud is, they usually respond with like our pictures, our videos, and then we always take the discussion towards understanding that if you put something on the cloud, it's there to stay. But we're not going to talk about this today, of course. There are a lot of things that we think is cloud. Let's see how we feel at the end of this webcast. So let's talk quickly about the evaluation. So computers started around 1960. We have the mainframe computer. Around 1980s, there's a time called cluster computing. Some places call it consolidation of mainframe. But the idea was to have a machine within the few machines within the cluster that were connected to each other by a network with high bandwidth. This was much cheaper than the mainframe system because you could consolidate and work on few of them at the same time. So that created a lot of more bandwidth and was cheaper, but still kind of expensive and limits you geographically. So let's see what happened next. After that, we have the era of virtualization. Virtualization referred to the process of creating a virtual layer over the actual hardware that allows the user to run multiple instances simultaneously on the hardware. Basically, it's like a logical separation of the compute power. This is the key to cloud technology as we know it today. And of course, around 2007, we entering the era of cloud computing where we are today. So we said in the beginning, there were physical servers. Let's discuss physical servers. Just like FYI, I really love things that are clear, like advantages and disadvantages. You're probably going to see that a lot throughout this webcast. So physical server is usually referred to as a single tenant computer server, meaning that a specific physical server is designated to a single user. The resources and the components of the physical server are not shared between multiple users. Each physical server includes memory, process, networking, hard drive, and everything in between. This allows us to have complete control and pretty high performance because we are responsible for every single thing, from the bare metal to the application. But with great power comes great responsibility. And here we see the disadvantage. Because we're responsible for every single thing, we need to order the hardware, we need to ship it to the right location, we need to install all the operation system, we need to install the software, the application. It takes a lot of time. But not only that, if you already have the physical server installed, turning a server from a regular server to production server can take a few weeks. Also, because it's a single tenancy, you don't use the full compute power all the time, which creates a lot of waste. Also, if you want to scale, you literally need to add hardware. You need to have a bigger memory card or a different graphic card. And when I talk about it, I always remember this from Silicon Valley. I'm a big Silicon Valley fan. When Guilfoyle turns down their improp data room because they went to cloud, and you can see how everything is connected with like fans and wires, because every time they wanted to add more memory or more compute power, they needed to find a way to do it. Now, virtual machines. Let's dive into that. So virtual machines, it's actually a software computer used as emulation of the actual physical computer. A virtual server operates in a multi-tenancy environment, meaning that a few virtual machines run on the same physical hardware. In this case, the computing resources of a physical server are virtualized and shared among a few virtual machines running on it. The architecture of a virtual server is a little more complex than that of the physical server. We have the hypervisor. You have a few options of hypervisor. For example, Microsoft has the Microsoft Hyper-V. It's installed on top of the physical hardware, and that hypervisor is very lightweight and uses about like 1% of the physical compute power resources. The hypervisor then used to create and manage the virtual machines, which have their own virtual computing resources. After that, you can load multiple Ghost OS and servers application on top of the virtual hardware. Virtual servers allows you to run several OSs and several applications on the basis of sharing the physical hardware, which makes it more cost efficient than, of course, the option of a physical server. So a lot of advantages, but what are the disadvantages? So it still depends on a physical server because the virtual machines are installed on the physical hardware. It's still kind of costly, much less than the physical server, and of course, the options we discussed prior, because you still have a lot of hardware involved. And we still have some waste of the computer resources because you allocate the full virtual machine, but not always use it. And it still requires a long deployment time and maintenance. And then came the cloud. So what is cloud? Again, I love Silicon Valley. So this is very good way to explain cloud. Cloud is actually huge storage spaces with a lot of physical servers connected between one another in a network, and a lot of these storages facilities are connected between each other over the internet, and they spread out throughout the world. That allows you to use a lot of compute power anywhere and access it anywhere you are in the world. By the way, this place is very cold and very big, so remember to get a jacket if you go to visit. So what are the benefits of cloud computing? So of course, we started with that, and let's really dive into that. So because there's a lot of these warehouses all around the world, you're always up. You have the ability for disaster recovery. If something happens and one of those warehouses caught fire, you still will be available and in a different location. You can store as much data as you want off-site. You always productive. No IT maintenance costs, which is really like lowers your cost of ownership. You One thing there is not here, but I really think it's a cloud benefit. It's the innovation. Because of cloud vendors investing a lot of resources in making sure that the machines you're using, the platforms, and everything you use is up to date and like the newest models, you're always tapped into that innovation. Something that if you'll try to achieve yourself, it's going to be very, very hard and almost impossible. So, are there different ways to consume cloud? And the short answer is yes. There can be public cloud, it can be private cloud, or we can have the hybrid model. So what is private cloud? Private cloud often will be used when security requirements or access to the information or standard requirements prevent you from sharing infrastructure. Although I have to say that nowadays, public cloud vendors invest tremendous efforts to make sure that you can be as secured and as compliant on public cloud as you are on private cloud. Azure, for example, offers data centers with tier 4 classifications and other security solutions like Azure Defender, Front Door, and Application Gateway. Companies that choose private cloud will be, for example, military industries, banks, or insurance companies. They're still maybe afraid to share their knowledge and use public cloud, but I do have to say we have a few companies. We actually have an insurance company that is one of our amazing clients that is completely on cloud. Public cloud is the notable advantage of public cloud is that the organization only pays for the resources it's used. When your business is growing or it's operating on a budget, you really don't want to invest in pricey infrastructure that you need to maintain and fix or create your own cloud. The advantage stands out over the private infrastructure is the cost of the organization and the money, regardless of the degree you spend. If you create your own private cloud, you're investing a lot in it, and it doesn't matter how much you're going to use, you still have the price. But if you work on public cloud, you're going to pay only for the resources you actually use. But what if I want both? So introducing the hybrid cloud, of course. It can exist in a few a few models. One cloud provider that can give you the infrastructure, or a number of cloud providers that contribute different aspects. For example, some provide private infrastructure and some provide the public. Actually, one of those vendors can be the organization itself. Can create a small private cloud for maybe sensitive data or things they don't want to share, and use one of the main cloud vendors for the public cloud abilities. So public cloud. Who are the vendors? So we have three main vendors. We have the Google Cloud, which is called GCP. We have the Microsoft Cloud, which is called Azure in the middle. And we have the Amazon Cloud, which is AWS. If we're going to talk just a few seconds about Microsoft Azure, so Azure has more regions across the world than GCP and AWS put together. It's the biggest spread all around the world. You can see the different data center locations and growing, of course. Azure offers variety of different types of virtual machines, 90 compliances offers when we talk. You remember 2 slides ago about private cloud and the concerns of maybe why you should use private cloud. And Microsoft supports open source technology. I don't know if you guys know, but GitHub was purchased by Microsoft just 3 years ago. So let's talk about cloud computing trends. I said one of the things that I hear sometimes when we talk about cloud computing is that it's just a buzzword, where this is not the case. Cloud computing is rapidly growing. From 2018, we are seeing increase in adoption of cloud computing all around the world, specifically on public cloud. Nowadays, about 30% of the companies in the world are using public cloud. And in less than 10 years, which is a little after this slide permits us, we're going to see closer to 50% in public cloud computing adoption. So we're really shifting away from the traditional IT, moving very strongly towards the cloud and specifically towards public cloud. Guys, if you have any question, feel free to continue sending it in the chat. We're all happy to answer, of course, if you have any questions. So let's continue. I'm sure you guys hear a lot like the words or the acronyms, IaaS, PaaS, SaaS. Let's talk what they actually mean. So there's a different ways to consume or work on cloud. There's one option that's called infrastructure as a service, which is referred to as IaaS. You can see that it's on the left. Then we have platform as a service, which is referred to as PaaS, and software as a service, which is referred to as SaaS. As we move right on our screen, you get less control. Everything is, the light blue is the vendor responsibility and the dark blue is your management. So you can see as we move right on the screen, you have less and less responsibility and it's all managed by the vendors. But if you don't have responsibility, you don't have the freedom. So it's always like a trade-off. And let's take an example that so we can understand really what the difference is. So SQL Server. So you can buy a license for SQL Server and install it in your on-prem physical server. This is the left, the packaged software option. And you'll be responsible for making sure that you have network and storage and server and everything in between. If you work on cloud, you can take the same licensing you have, which is, by the way, Microsoft has the option of bring your own license. You don't need to repurchase it. And get a SQL Server virtual machine and run it. You're not responsible for the networking or the storage. You'll be responsible only from the OS and above. If we're talking about platform as a service, you can take a managed SQL Server and run it. Here, you're not responsible for the runtime or the OS. Just responsible for the data you're going to put on it and the application. If you're talking about SaaS, here I don't have a SQL Server example, but it's literally your 365. But let's just see if this is also an easier way to explain. So SaaS will be usually used by the end user. They just want to work. They don't need to code anything. They don't want to worry about anything related beyond the actual software they're using. PaaS platform as a service is usually the layer of the developers. They need the platform to work on it and be able to write their code without any concern. The IaaS layer is actually where we at to be cloud. It's a more professional layer. It's more in the infrastructure world. It's referred to sometimes as infrastructure as code. Here, you take a lot of the ownership. You don't really touch the iron, of course. This is a different position. But here you need to have a lot of knowledge and to know how to work with this layer in order to allow all the layers above you to perform their tasks. One thing about me is I'm a big foodie. I love food, and I think everything is better understood with food. So the pizza as a service model. So if we compare from on-prem to software to pizza. So the traditional on-premise is you're made at home. So you need to create the dough, you need to invest your time in it, the oven, the gas, the soda, what you're gonna drink, the toppings, everything is in your responsibility. The infrastructure as a service, the IaaS is already like a take and bake. So we have the pizza dough ready. We need to add the toppings. We need to put it in the oven. We need to set the table and the drinks. The platform as a service is delivered pizza. The pizza is ready. I don't need to do anything in the kitchen. Just set the table, drinks, and eat. And the software as a service is dine out. I come, I order, I eat, I go. Nothing is my responsibility. So here it really depends on how much freedom you want, if you love your toppings, if you want to make your own dough. It's pretty much the same in cloud. You'll need to decide how much freedom you want to have, but also the same amount of responsibility. What's next? We had a physical server, then virtualization and to cloud. Now we're entering the world of serverless and containers. So let's take the time that we have left to understand, first of all, what do they mean and which one is actually better. So containers. Containers is a packaging of the software code so that it will run consistently no matter the infrastructure or the operation system. I'm sure all of you heard the sentence sometimes, but on my computer, it worked perfectly. Yes, it did, because when the author created it, he thought about the operation system, the platforms, and everything he created that piece of code on to make sure that it runs. But when the reader takes it, he doesn't know the exact thought that was there. So this is what containers do. You basically wrap everything together from the language that it was written on, the operation system, the platform, and everything you need to deploy and make sure that it runs on any other computer, no matter what. The containers are often called lightweight, as they are very much smaller in capacity than a virtual machine and require less startup time. Therefore, the server is more efficient, and containers reduce server and licensing cost. For advantages and disadvantages, so you're going to get here the same thing. So if we're talking about the benefits, it is light and does not contain more than what the app actually needs to run. It can run on any platform that supports containers management, such as Kubernetes. Because it's light, it has short uptime from deployment, quick runtime, and fast setup time compared to a virtual machine. The containers are isolated, are small isolated environment, and that allows a server that has several different containers to run on the same physical environment, and this is decreasing the cost by a lot. Some disadvantages. This is not a real, like an exact disadvantage, at least on my end, but containers are adapted to run on a microservice environment, although you can run them on a monolithic architecture as well. Because containers are in the IaaS level, that means that the scalability, the high availability, and the performance are in the hand of the end user. Remember, responsibility, the more freedom you want, the more responsibility you get. Although, if you're working on the IaaS level, again, you are probably anticipating it. And one last thing, containers require active monitoring, auditing, and maintenance. But there are already a few automatic scaling and monitoring solutions out there that you can implement when you're working on containers. Serverless. So what is serverless? It's not really without server because we said cloud is still actual servers, but what does it mean? Serverless is actually cloud service where the provider allocates the resources needed by the user according to real-time consumption so that he's not really required to pay in advance for a dedicated volume of service. Serverless is the next step in development of the infrastructure as a service IaaS world. This technology makes the infrastructure transparent to the developer so that its running and management of the environment become completely virtual. It's more in the PaaS level, or sometimes it even refers to as function as a service. Allows the developers to work without worrying about the servers, the virtual machine, or the other basic computing resources. And our favorite advantage and disadvantage. So serverless are much less expensive than all the options we have talked about so far because you're paying accordingly to the runtime and not anything beyond that. You don't have anything in idle. It's sort of a black box where everything that has to do with the processing is packed together. You just need to worry about the application, and that's it. But if you're looking about on the disadvantages, there are a lot of small pieces that need to play together. And it's not only a challenge, but it also can create a lot of latency. Serverless is at the level of PaaS, platform as a service, as I mentioned before. So remember, you just bring the application, but it can create a vendor lock because you're not as freed as working on the infrastructure level. Always remember, although it's counterintuitive, the more responsibility you have, the more freedom. So serverless versus containers. Serverless is a black box. And with containers, you have more control. If you're looking to scale in serverless, all your concern for scale depend. It's actually the vendor's responsibility. They know how to allocate what it takes to run a specific string of code automatically without you worrying. In containers, you need to make sure that they're running, but there are platforms that you can use to manage the scale, like Kubernetes. But maybe you want to choose to do it yourself. Also, if we're talking about vendor responsibility, everything related to the environment management and software update in serverless is the full responsibility of the vendor compared to containerized, where the responsibility and everything around it is the end user responsibility. We talked about vendor lock. Containers will run everywhere, no matter what, because they're operating on the IaaS level. But it's not the case of serverless. What is better? This is actually the mother of all questions. Like, what's better? What is the future? Will it be containers or serverless? So there are many disagreements, and there's no one actual true answer. The decision is basically depends on you. If you want to achieve productivity, but sometimes at the price of infrastructural freedom, you'll probably go serverless. Although there still will be cases where serverless ability will limit you, so beware. The optimal solution will probably a combination between the two that will give you the benefits of enjoying serverless, but at the same time, some of it probably will be on containers and allow you for the freedom and to not be locked in. I always like to end with real life scenarios. So this is one of our amazing customers who's an online retail company. Unfortunately, I can't send their name right now. But when they came to us, they had about 150,000 visitors a month. And their website is how they sell their product. But they suffered from downtime, and especially around the weekends and evenings when they had this spike in visitors. That really was difficult for them to scale. We introduced few solutions. Some of them were Azure Front Door and Azure Autoscaler to their existing service app service environment, and that stabilized the environment enough for them to scale 5 times more. They now have 750,000 visitors a month. And we're actually gearing up for a nationwide campaign with one of most amazing pop stars that has over 10 million followers on Instagram. And they're anticipating actually 1 million visitors over the course of 2 weeks during this campaign. And we're confident that with their existing environment, they're gonna breeze through that. So unfortunately, I can't say right now who they are, but I'm sure that once you see the campaign, you'll know exactly what I'm talking about. So if you're ready to take your first step towards mastering your cloud, we'll be happy to help you do that and answer any question you have. So feel free either to visit us on our website at tobecloud.io, or you can contact our country manager, Gilad, at GILAD at tobecloud.io, or just scan the QR code you see here on the screen and leave your information. And one of our cloud experts will get back to you as soon as possible and make sure to answer all your questions and help you master the cloud. So thank you guys, and continue asking your questions in the chat. We're here to answer and hope you enjoy this webcast.